Assalamu alaikum dear students. This is our second video in unit number 6, plane analytic geometry. In the first video we have derived distance formula that gives the distance between 2 points in the plane. Now first we are recalling that formula. The distance between 2 points in the plane A and B is given by this one. AB modulus is equal to x2 minus x1 square plus y2 minus y1 square whole square root. Dear students, here x2 minus x1 is the difference between x coordinate and y2 minus y1 is the difference between y coordinates. So we can say that the square of the difference of the x coordinate and the square of the difference of the y coordinates. Now we come to certain questions which uses this formula. This is example 6.1 and 2, and the statement of this example we have show that the triangle with vertices A, B and C is a right angled triangle. Dear students, you know that a right angled triangle is the triangle which obeys Pythagoras law. And you know Pythagoras law that square of hypotenuse is equal to square of base plus square of perpendicular. Dear students, base and perpendiculars are also called the legs of the triangle. So we can say that the square of the hypotenuse is equal to the sum of the square of the legs of the triangle. But dear students, how to use this idea in the questions? For this we observe that hypotenuse is always the largest side of a right angled triangle. So hypotenuse can be replaced by the largest side and the other two sides which are called the legs of the triangle. Now this can be replaced by the alternative statement that square of the largest side is equal to sum of the squares of the other two sides. So if in the question we show that the square of the largest side is the sum of the squares of the remaining two sides, the vertices, the points will denote the vertices of the right angled triangle. Now we come to the solution of the question. Dear students, we are given 3 points A, B and C. For this we have to show that these 3 points satisfy this relation. Now first we are going to find the distance AB, the distance BC and the distance AC, which are the perpendicular base and hypotenuse of the triangle. Dear students, from here we observe that the distance formula can be used in the pattern that the difference of the x coordinate and the difference of the y coordinates. So AB distance, we can calculate it. So the difference of the x coordinate, from the first coordinate we subtract first coordinate, and from the second coordinate we subtract the second coordinate. So when we are calculating AB, we are taking A as the first point and B as the second point, and we are subtracting the coordinates of the second point from the coordinates of the first point. So here AB minus 2 minus 2, the difference of the x coordinate, and similarly the difference of the y coordinates is minus 3 minus 1. So we have minus 2 minus 2 square minus 3 minus 1 square, minus 4 square is 16 and minus 4 square is 16. So this AB distance is equal to square root of 32. As you have observed it in the case of the Pythagoras law, we are using the squares of the sides, so we are squaring both sides. So AB modulus square is equal to 32. Now we have to calculate BC distance. We have to use the same pattern that we are subtracting the coordinates of the second point from the coordinates of the first point. Now the difference of the x coordinate is 2 minus minus 2, which is 2 plus 2, and 1 minus 5. It is given here. Positive 4 square is 16 and negative 4 square is again 16. So we have BC distance square root of 32. Squaring both sides we get 32. Now we come to the third side, which is AC. Now AC distance is equal to first coordinate minus first coordinate. So this is minus 2 minus minus, which becomes plus. So minus 2 plus 2 square and minus 3 minus 5 whole square. So we have 0 square, which is 0, and minus 8 square, which is equal to 64. So here we have AC distance is equal to square root of 64. Squaring both sides we get this. Dear students, you observe that 32 plus 32 32 plus 32 is equal to 64. So the sum of these two sides is equal to this one, and this is AB square, this is BC modulus square, and this is AC modulus square. So we observe that AB modulus square plus BC modulus square is equal to AC modulus square, and it is given here. You have observed that the square of the largest side is equal to the sum of the squares of the remaining two sides. So this is obeyed, and you know that this is an alternative statement of the Pythagoras law. So Pythagoras law is obeyed, and you know that when Pythagoras law is obeyed, the triangle is called a right angled triangle. Hence the given 3 points are the vertices of a right angled triangle. Now students, we come to question number 2. In the statement of the question, we are given 3 points, and we are to show that this relation is absurd. Students, we have A, B, and C as 3 points, and we have to show that AB distance plus BC distance is equal to AC distance. You observe that again we have to find AB modulus, BC modulus, and AC modulus, and then we have to observe this relation. We have to again apply the distance formula. From distance formula, we have AB. We are subtracting the coordinates of point B from the coordinates of point A, and you know the distance formula say the difference of the x coordinates square, difference of the y coordinates squares. So we are subtracting the first coordinate from the first coordinate and taking square. So -1 -2 whole square, and we are subtracting second coordinate from the second coordinate. So 3 minus 1 whole square. Here we have -3 square 9 and 2 square 4. This is square root of 13. Similarly, BC, you are subtracting the coordinates of point C from the coordinates of point B. So from first we are subtracting first coordinate, and from second we are subtracting second coordinate. So we have 2 minus 5 and 1 plus 1. This is -3 square 9, and this is 2 square 4. This is again square root of 13. AC, we are subtracting the coordinate of point C from the coordinates of point A. So we have from first we are subtracting first, and from second we are subtracting second. So we have -1 minus 5 whole square, 3 minus minus, which is plus, so 3 plus 1 square. This is -6 square 36, and plus 4 square is 16. Adding these two, we get 52. 52 is equal to 3 multiplied by 13, 4 multiplied by 13, and the square root of 4 is 2. So we have 2 times square root of 13. You observe that when we are adding these two, we get 2 times square root of 13, which is this one. So we have that 2 square root of 13 is equal to this one. Now AB modulus plus BC modulus. This is AB modulus, this is BC modulus. Adding up these two, we get 2 square root of 13. But you observe that 2 square root of 13 is here, which is equal to AC distance. Thus we observe that AB distance plus BC distance is equal to AC distance, and the condition is absurd. Dear students, sometimes in MCQs such a relation is asked. Be careful that if A, B, and C are 3 points on a straight line, then the distance of AB plus the distance of BC is the distance of AC. So if we observe this relation, AB plus BC is equal to AC, then we have that these are 3 points on the same straight line. So we can say that the points A, B, and C are collinear. Collinear means line on the same line. Now dear students, we come to question number 3. This question says that show that the points A, B, and C, D are the vertices of a square ABCD. Before going to start this question, we come to the definition of a square. Dear students, square is a tetrahedron, a 4-sided closed geometrical figure, all whose sides have equal length and whose diagonals are equal in length. So if we show that in a tetrahedron, a 4-sided closed geometrical figure, all the sides are equal in length and the diagonals are equal in length, then the tetrahedron would be called a square. So for this we have to show that distance AB is equal to distance BC is equal to distance CD is equal to distance AD or DA. Similarly, we have to show that the diagonal BD and the diagonal AC are equal in length. If we show that all the four sides are equal in length and both these diagonals are equal in length, then the tetrahedron would be called square. Now, I come to my notes, expert notes. Students, this is the question. You are familiar with the distance formula, so you can use the distance formula yourself and you can do this calculation because it is quite easy. Having A, B, C and D as 4 points, applying the distance formula, we have AB distance, AB modulus is equal to square root 18, BC modulus is equal to square root 18. Similarly, CD modulus is equal to square root 18 and DA modulus or AD modulus is equal to square root 18. Dear students, you observe that AB, BC, CD and DA are the four sides of the tetrahedron. We observe that AB distance is equal to BC, BC is equal to CD and CD is equal to DA. So we have that all the four sides are equal in length. Now we come to the lengths of the diagonal. We have to show that both the diagonals are equal in length. Now from here we observe that AC distance is equal to 6 and BD distance is equal to 6. AC and BD are the diagonals of the tetrahedron and we have observed that both the diagonals are equal. So here we have observed that all the four sides are equal and here we are observing that both the diagonals are equal. All the sides are equal and both the diagonals are equal. And you know that when all the four sides of a tetrahedron are equal and both the diagonals of the tetrahedron are equal, such a tetrahedron is called square. So we have observed that A, B, C and D are the vertices of a square. Dear students, now we come to question number 4. In the statement of the question number 4, it is given that show that the 4 points A, B, C and D are the vertices of a rectangle ABCD. Dear students, rectangle is also a tetrahedron, but in case of the rectangle, the opposite sides are equal and the diagonals are equal. Here we observe that AB is the opposite side of CD and AD is the opposite side of BC. So in a rectangle, we have to show that the opposite sides are equal, that is AB is equal to CD and BC is equal to AD, and the diagonals are equal, that is AC is equal to BD. Again, we have to apply the distance formula. Now, we come to this question. This is the next question. A, B, C and D are the vertices of a rectangle. We have to show this. Again, students, we are applying the distance formula with which you are familiar. AB distance is equal to square root 180, BC distance is equal to square root 50, CD distance is equal to square root 180 and DA distance is equal to square root 150. Dear students, you have observed that AB and CD are the opposite sides. So these two opposite sides are equal in length. Similarly, BC and DA are opposite sides and these two opposite sides are equal in lengths. Now we come to the diagonals, which are AC and BD. Dear students, AC length is equal to square root of 680 and BD length is equal to square root of 680. Thus we have observed that both the diagonals are also equal in length. From the calculations, we have observed that AB is equal to CD and similarly AD is equal to BC. Thus opposite sides are equal in length, and also we have shown that AC is equal to BD and both the diagonals are equal in length. So we have observed that in this case, in this tetrahedron, the pair of opposite sides are equal in length and both the diagonals are equal in length, and you know that such a tetrahedron is called rectangle. Hence we have proved that A, B, C and D are the vertices of a rectangle ABCD. This is the end of the second video. Khuda Hafiz.